Hello, this is Tuğba Ayhan and this video is about ADC fundamentals. An ADC is an analog to digital converter which is used for quantization. So it means conversion of a continuous analog signal into a proportional multi-bit binary word. As in the DAC case, we can talk about the step size. Step size is defined as this formula. VRH is the high reference voltage and VRL is the low reference voltage. So the signal will change between high reference and low reference, and they will be represented with n bits. So the step size will be the difference between the reference voltages divided by 2 to the power of n. So we can change this to that second form. The output data is equal to V in, the analog input, minus the low reference times step size. So as you can see here, sometimes the maximum and minimum voltages of the input can be different than the reference voltages. We can again talk about resolution, accuracy, DNL and INL specifications like we did in the DAC. So the definitions are exactly the same. So there's a very small example here. What's the resolution and worst case error for a 10-bit ADC with a high reference of 5 volts and low reference of 0 volts and an accuracy of 0.05%. So to calculate the resolution, you need to use high reference voltage and low reference voltage difference and 2 to the power of n. N is 10 in this example. Actually, the accuracy is given as 0.05%. So in terms of volts, the accuracy is 0.05% times the step size. Step size is equal to the resolution. We have two more specifications different than DAC. First of them is the conversion time. It is the amount of time required to perform a conversion. Faster ADCs are also more expensive. Another timing specification is aperture time. It is the amount of time the input signal is actually observed by the ADC. Aperture time is usually equal to the conversion time. If the input signal changes by more than 1 LSB during the conversion time, there will be an error at the output. So to prevent that error, a sample and hold circuitry is required. If there is an internal sample and hold inside the ADC, we can observe for a short time even if ADC conversion time is longer. So aperture time is usually equal to conversion time, but sometimes if the sample and hold circuitry is required and is used, then aperture time is smaller than the conversion time.